All right. In the hold on a second. Let me just log into something real quick. In the topics of science uh, class, on the right-hand side, you'll see two things in the upcoming. The one of them is uh, the solar car design activity, which I told you about on Monday and also again on yesterday. And then the other thing that you'll see is the solar car race activity. And the solar car race activity, I just posted that today. Actually, it might have been up yesterday. Just give me 1 second here. There we go. Someone else coming in. All right. So on the right-hand side, the solar car design activity, you know all about that. And if you need more information or instruction about that, uh, in the plan for the week on Monday, there is the Zoom recording that you can review. Or if you click on the activity itself, the links for the YouTube uh, video about designing, engineering, and testing solar cars is in there. You need to complete this today. So if you've already got it done, and a bunch of you got it done and submitted it even on Monday, but if you didn't get it done yesterday or Monday or yesterday, you got to get it done today. The second thing on the upcoming is the solar car race activity. So these are the two activities for this week: solar car design and solar car race. You can get to it by clicking there, but you can also get to it in the materials. In the materials section of the course, there's a folder that says solar car project, the current activity. And in there is the plan for the week. If you click on plan for the week, you'll find the Zoom recording from Monday where I describe everything about the solar car design activity. The solar car race activity information will be right here where it'll say Zoom recording right here for what I'm about to talk about right now in class. So the solar car race activity is done the same sort of way. If you click on the solar car race activity, it'll open up a SharePoint document or a OneDrive document. And as soon as you start typing in this, it'll automatically save. It creates a copy just for you. And in this document, there are two links. One of the links says bit.ly/lightspeed playlist. And that's the playlist for all of the videos in this video series. So it turns out that somebody else coming in. In this video series, there's the trailer, which I showed on Monday, and then on, come on, copy that. There we go. Actually, I think it might be up here. Nope. Okay, so there's the trailer, and then there are these 6 episodes. Episode 1 is the one you watched, Engineering the World's Fastest Solar Race Cars. And then episodes 2, 3, 4, 5, and 6 follow each day of the race. And if you want to, you can watch episode 2, 3, 4, and 5. And those show you days 1, 2, 3, and 4 of the race. You don't have to watch them, but it's interesting to see like what each of the teams goes through. Some of the cars wreck, some of the cars catch on fire, some of the cars just break, some of the cars are fast, some of the cars are slow. Some teams get penalties for breaking rules. Some teams get to take advantage of situations. There's all kinds of different things that happen on days 1, 2, 3, and 4 of the race. But you don't have to watch them all. This is the link that takes you to day 6. So either if you're in this list of all of them, it's actually episode 6, which is day 5 of the race, the final day of the race. And in this last video, it shows a brief overview of the 5 days of racing. But the smart thing to do before you watch the video is to preview the questions. And the questions are applications of things that you see. So the first thing is there are 3 teams that are very close to each other at the beginning of the last day. The 4th place team is a team from the United States. Where's that team from? The second question, why is it dangerous for batteries charged to get too low? So it turns out like, that if your cell phone battery gets low, it'll, just die, and that's inconvenient. But large format lithium-ion batteries, like the ones that are used in these cars, um, if the charge gets very low and you put a lot of current on them, there is something that's dangerous that can happen, and you'll actually see it happen in this video. They talk about that issue about battery charge getting too low, and it's an issue with electric cars and solar cars. The third thing, Team
That's
Vattenfall.
definitely. I got a question.
Yeah, what's up?
What are them batteries that if you like charge them to 100, well, like next time it'll charge to like 90 and then 80, or like it'll keep getting lower or whatever?
Yeah, well, there's an older type of rechargeable battery. They were called NiCad batteries. They're nickel cadmium batteries. And it used to be with rechargeable batteries, it was very important to discharge them all the way and then charge them up all the way. And if you didn't do that, they would develop what's called battery memory, where, like, let's say you discharged it to halfway, then when you recharge it, it won't charge the entire way back up. So those old NiCad batteries aren't very common. They were used in like a lot of battery powered hand tools and remote control cars, kind of like back in the day. But now we mostly use a class of batteries called uh, lithium ion batteries or nickel metal hydride batteries. And they don't have that battery memory, which is good. But all batteries degrade over time. Like, you know that, like, if you get a brand new cell phone or a brand new laptop or have a brand new, like, a rechargeable battery for a drill or something, it works great right off the bat. But over time, the battery's not able to hold as much charge. And that's one of the big things about design and engineering of electrical systems is having better batteries. Rechargeable batteries are worlds better now than they were, just like a decade or two ago. But there's still room to go. We still want to be able to have like even more charge, generate less heat, just make them work perfectly. So that's a big deal. So in this video, there's issues about if batteries charges get too low. Usually with rechargeable batteries, you don't actually try to discharge them the whole way anyway. And it's because of this kind of issue. Anyway, so the third question, Team Vattenfall doesn't finish the race. Why were they eliminated from the race? What happened to that team that they didn't get to finish? The final miles of the race are difficult for the drivers. What is tough about driving where the race ends in Adelaide, Australia? You'll see them talk about a couple different issues about why it's tough driving these solar cars in Adelaide, and then which team ends up winning the race. So this video that I have the link for takes you through this YouTube video, and it straight up says, the title is Catastrophe on the Final Stretch. So that kind of gives you a hint that something bad happens to one of the teams. No one gets hurt, no one gets killed, so it's not like that. But any kind of failure of a car is catastrophic. Here you can see the car is moving along at a pretty good clip. They can do 60 miles an hour or so. You read
I might have to do this tomorrow.
That's cool. You read about and saw how they.
I'm not allowed to watch anything.
I got you.
I'm going to get cleared tomorrow.
Yeah, you can even just listen to it. And, like, that's,
Why is most of the solar cars, like, I'm watching it right now, why is most of them, like, over on the right, like the seat is? Wouldn't it be, like, more convenient to have the seat in the middle and then have the solar panels around that?
Yeah, well, there's two different designs. There's one they call the bullet design, where it's just one tube, and then they sit in the middle. The Michigan and Stanford team from the United States like that. And then there are these other cars that are, they call it a catamaran design, where there's
all the way on the right.
Yeah. So the right might seem weird, but you'll notice that in this film in Australia, they drive on the opposite side of the road as we do. And the driver needs to be on the inside part of the road. So if you drive on the left lane, it's right-hand drive. So that's the way they make these. Same as, like, here we drive on the right side of the road, so we have left-hand drive vehicles mostly. Some countries of the world, they drive on the right side with right side drive. If you go to, actually in the United States, if you go to the US Virgin Islands, all of the vehicles are left-hand drive, like our cars we have here, but they drive on the right side of the road or the left side of the road. So the driver actually drives against the shoulder. Like, in other words, like when you drive a car, your body is close to the center of the road, and that helps you judge to make sure that you don't hit someone head on. But in the U.S. Virgin Islands, the driver is on the shoulder side of the road, so it's more difficult to judge if you're gonna like get in a head-on collision. They actually have more head-on collisions. So that's why we drive on the side of the. That's why we sit on the side of the car, based upon the side of the road that you drive on. But anyway, so this last one is 19 minutes long. That's actually the Team Vattenfall car, and you get a good sense as to the size and scope of the whole race. So anyway, it's pretty good. It's an awesome series, and it turns out that that last episode was actually just released yesterday. You could watch it as YouTube Premium, but it was just released yesterday as like a free to watch episode. So I kind of had to wait for it to.
So do you have
catch up.
the watch the last one also?
What's that?
I'm taking it. You have to watch the last video too
Yeah.
to see who wins.
Yep. Well,
Okay.
so I mean, you're only actually watching the first one, which you already watched in Solar Car Design, and then you watch the last one,
Yeah.
which is it shows you the winner, but it shows you other things that happen and strategy and stuff. But you could watch the other ones; they're pretty good.
All right, can I go get started?
I actually enjoyed watching
Alright.
the thing, so but whatever. All right, so that's what you got to do. If you have questions, you can put them in the chat, or you can turn on your mic and ask. Otherwise, if you need to finish the solar car design activity, you can finish that now and today. If you need to finish the, let's see, help you when you're done. Yep. If you need the solar car, if you want to do the solar car race activity, you can do that, now and just get it done by Friday. Okay.
All right, I'll see you later.
All right. Keep it real.
See you, Flame.
Yep. El Nino web quest. Yeah. Sorry about that. All right. So what are you looking for help about? Number 5. Oh yeah. I'm sorry. I thought I might have missed it or forgot. I remember you asked about that before, but maybe you left before I got to it or something. All right. Let me take a look. Topics of science. I clicked on the wrong one. Remote learning for November, December. Just takes me a minute to get to it. Yep. Okay, so is the Pacific Ocean in the Eastern Pacific currently warmer or cooler than usual? All right, so this is the Pacific Ocean here. So like North America is like this, and this is Asia over here in Australia. When we're in El Nino, this water in the western part is warm, and the water in the water in the western part is cool. The water in the eastern part is warm. But then if we're in La Nina, then the water near North America, this is like where North America is. We're like up here. But the water near North America is cool and the water near Asia is warm. So it like switches back and forth. Anyway, so we're in a La Nina. So if we're in La Nina, then the Eastern Pacific Ocean is cool. The Western Pacific Ocean is warm. So is the Pacific Ocean in the Eastern Pacific warmer or cooler than usual? This is the Eastern Pacific Ocean. It's cooler. Does that make sense how you read the map? Okay, cool. You have other questions or anything else?